Significant figures. All right, let's talk a little bit about significant figures. We've talked about it in class, and it's part of our Chapter 2 lecture. However, I thought it would be good to make a short video on just a brief review of significant figures for those of us who maybe get a little rusty throughout the year, because we do use significant figures throughout the year with all of our measurements. First of all, what are significant figures? Well, significant figures, sometimes referred to as sig figs, or I call them sig figs a lot of times, are the numbers that tell us the precision of our measurements. The precision of our measurements. And that precision, or the consistency of our measurements, typically comes from our instrument. Okay, our instrument. So let's look at kind of a brief review on actually making measurements. I've got two line segments that are exactly the same. I'm going to have two instruments up here for us to look at. Okay, this first instrument is precise, or has the smallest divisions are to the ones place. So we have to estimate the next place value, which is the tenths place. So the measurement of this line segment with this instrument would be 4.5. Now, someone looking at this measurement may say, oh, that's not 4.5, maybe it's 4.4. Well, that last estimated digit could be different depending on the observer that's actually making the measurement. And that's okay if that last digit is different, because scientists understand when we look at measurements, the last digit is always an estimated digit. Now, if I were to get a more precise instrument, okay, this second ruler goes to the tenths place. We say that it is more precise. Well, if we actually look at where this falls, we would say that this goes past the 4, so it's 4 point, because these little divisions are tenths. 1, 2, 3, 4, 5, so it's 4.5. And then, since this ruler reads to the tenths place, our estimated digit has to be to the hundredths place. So our final measurement is going to be 4.54, or I say 4.55 centimeters. Now, it's important that we include the units on both of our measurements, because numbers without units are meaningless. Okay? Sigfigs tell us how good or precise our measuring devices are. The better the instrument, the better the precision. So the more divisions you have, the more precise your instrument is going to be. Thus, the more significant figures you will have. Essentially, the more decimal places. If you're looking at place value, you have a decimal. Okay, the more decimal places you have, or the more to the right on place value, the instrument's more precise. The more to the left of place value, the instrument is less precise. So, when counting significant figures, we're looking at another measurement on paper. Maybe it's not necessarily a measurement that we took, but when counting significant figures, we're looking at someone else's measurement. We have two rules really for counting significant figures. All numbers are significant except for zeros. Sometimes zeros are significant, sometimes they're not. Zeros, leading zeros, or zeros that come at the beginning of a number, are never, ever, ever significant. So all of these zeros, since they're coming at the beginning of the number, are considered leading zeros. Leading zeros are never, ever, ever significant. Trailing zeros, numbers that come at the end of the number without a decimal, this number does not have a decimal, they are not significant. Now, these zeros are important because we use them as placeholders. That sets the magnitude of our measurement. However, they are not significant because, remember, significant figures tell us the precision of the instrument that we are using. Significant figures tell us the precision. These zeros, leading and trailing zeros, they're important because they're placeholders. They keep the meaning of the measurement. However, they're not significant because they don't tell us anything about the instrument. On this one is still a leading zero, so it's not significant. 500 right here, these two zeros are not significant There's no decimal, but if I were to have 500 and then a decimal point, that would make these zeros significant. These would be trailing zeros, and they have a decimal point. Okay? If the scientist takes the time to put that decimal point, then these numbers are significant. These zeros are also trailing zeros, but they're significant because there's a decimal point in the number. A decimal point automatically makes any trailing zero in a number significant. But remember, leading zeros are never, ever, ever significant. So how are we going to use this counting significant figures and making calculations of significant figures? Well, we use it with our calculations. When performing calculations in science, chemistry, physics, physical science, it's important to use significant figures to express the precision of our instruments. When we are scientists, we never want to overstate our precision, okay, especially when you're dealing with medicines and human body type deals. When reporting our final answer in a calculation, remember calculations, adding, subtracting, multiplying, dividing, the final answer can only be as good as our least precise measurement or the one with the fewest significant figures. Okay? So we have a couple of different rules. Multiplication and division, that's the most popular operation that we use in chemistry, so I'm going to cover that one first. Use the number with the least amount of sig figs. Okay, so we count the significant figures in each of the factors that we're multiplying together, and the number with the fewest tells us how many significant figures our final answer is going to have. For example, 2.0 times 3.74. Well, that's an easy calculation. We put that in our calculator, or we can do it in our head. That equals 7.48, but 7.48 is not going to be our final answer. We have to look at significant figures. 2.0 has two significant figures. This zero is significant. It's a trailing zero, but it has a decimal. That decimal makes it significant. The second number has three significant figures. Okay, according to this rule, our final answer can only have the fewest amount. So which one's smaller? 2. So our final answer can only have two significant figures. So we start counting 1, 2. Well, that 8 makes that 4 round up to a 5, so we end up with 7.5. Now, what if we are dividing? Well, let's try dividing. 4.00 divided by 2.0. Our calculator is probably just going to tell us 2. Okay? Now we need to figure out significant figures. 4.00 has three significant figures because these zeros are significant. 2.0 has two significant figures because this zero is again significant. These are both trailing zeros and they have decimal points. So our final answer has to have two significant figures. Well, in order to express this in two significant figures, we have to add a trailing zero with a decimal. Multiplication, division, the most popular operations. Now, addition and subtraction, we have to look at a little bit differently. Okay, still similar, but a little bit differently. We use the least precise place value, or the significant figure that is furthest to the left. For example, if I were to ask you to add 200 plus 53.74, alright, this top number is precise to the hundreds place. The zeros are not significant, so the last significant figure is in the hundreds place. The bottom number is significant to the hundredths place. Okay? Our final measurement can only be precise to the least precise measurement, which is the 200. The 200 is in the hundreds place. So our final answer has to go to the hundreds place. Well, that 5 is going to make that 2 do what? Well, it's going to make it go up to a 300. So this final measurement is precise to the hundreds place. Okay? What about a subtraction problem? If I subtract 4.00 minus 2.0, your calculator is going to tell you 2. Now, the top number is precise to the hundredths place. The bottom number is precise to the tenths place. Our final measurement must be reported to the least precise place value, which is going to be the tenths, the one that's furthest to the left. So our final answer, we would have to add a 0.0 so that it would be precise or significant to the tenths place. Now, sometimes it may be necessary to convert our numbers into scientific notation in order to report the correct number of significant figures. For example, if I had to report 2,000 to two significant figures, well, I can't really effectively do that, and because if I were to put a decimal point here to make these trailing zeros significant, that would be precise to the ones place, and that would give me 4 significant figures, but I only need 2 significant figures. The only way to do that would be to report it into scientific notation, 2.0 times 10 to the negative third, because this would then be the hundreds place, or the second significant figure in this measurement. Okay, scientific notation would just look at the number in front of the times 10 to your exponent. The times 10 to the third doesn't mean anything in terms of significant figures. If we had to report 2,000 to the tens place, okay, to the tens place, we would simply report it as 2.00 times 10 to the third. Okay, that would also be 3 significant figures. So hopefully that kind of helps you review what significant figures are, and you'll be good at it.